Assalamualaikum, my name is Nuliana. So today I will explain about introduction. So firstly, we need to know the meaning of titration and back titration. So the titration, or known as a direct titration, is a quantity technique where neutralization is used to determine the concentration of one solution back. So the next one, we go to the back titration. Back titration, also known as indirect titration, is a method used in analytic chemistry to determine the concentration of analytic by reacting it with a non-excess of a standard reagent. Back titration is a valuable technique in analytic chemistry, enabling determination of various substances complex matrices, or when direct titration is impractical. The excess reagent can be added until the analyte is completely reacted with the reagent, which can give more accurate result than direct titration. Back titration can be performed even when the sample is insoluble in water. Back titration is typically applied in acid-base titration.
Assalamualaikum, my name is Muhammad Shahar Fakhruba, and now I will talk about the theory and concept of back titration. So what is back titration? Back titration, also known as indirect titration, is a method of chemical analysis used to determine the concentration of an analyte by reacting with a non-excess of reagent, and then titrating the remaining excess reagent with a second reagent. This technique is particularly useful when the analyte does not react directly with the titrate, or when the endpoint of the direct titration is difficult to determine accurately. So next I will talk about the concept of back titration. The first one, addition of excess reagent. A non-excess amount of a reagent A is added to the analyte substance being analyzed. Second, reaction. The analyte reacts with the excess reagent. The reaction should go to completion. The third one, excess reagent determination. The amount of the excess reagent A remaining after the reaction is determined by titration with another reagent B. And the last one, calculation. The amount of the reagent A that reacted with the analyte is calculated by subtracting the amount of reagent A that remained from the total amount initially added. This information is used to determine the concentration of the analyte.
Assalamualaikum and hi, my name is Nur Kamarina. So for the back titration experiment, we need apparatus and chemical reagent. The apparatus that we need is 1 250 ml volumetric flask and 2 for 100 ml volumetric flask. We need retort stand and 3 250 ml conical flask, 20 ml and 25 ml pipette, burette, weighing paper, filter tunnel and a dropper. The chemical reagent that we need is 50 ml or 100 ml 1 molar NaOH, the indicator which is phenol red or phenolphthalein, aspirin tablet, 300 mg ASA, and lastly we need 0.1 molar HCl for 250 ml solution. This is the methodology of back titration experiment. The example that we use is aspirin. Firstly, we have to do the preparation of solution. We have to prepare 1 molar NaOH solution for 50 ml, 0.1 molar HCl solution for 250 ml, and 0.05 molar Na2CO3 for 100 ml solution. Secondly, we have to do the standardization of HCl solution. We have to standardize HCl solution with Na2CO3 using proper procedure. Thirdly, we have to do the hydrolysis of aspirin. Firstly, we have to weigh accurately a definite number of aspirin tablets which no more than 1.5 gram. Secondly, we have to weigh the aspirin tablet accurately in a weighing paper and transfer the tablets into a 250 ml conical flask. Thirdly, we have to add 25 ml of 1.0 molar NaOH solution using pipette and 25 ml of water to the tablet. Heat the mixture until it boils for about 10 minutes in order to hydrolyze the aspirin. The fourth step is to cool the solution at room temperature, then transfer quantitatively into 250 ml volumetric flask. Dilute the solution to the mark carefully using a dropper when the level is close to the calibration mark. The last procedure is we have to do the back titration. Firstly, we have to pipette 20 ml of aspirin solution into a 250 ml conical flask. Secondly, we have to add 1 to 2 drops of phenol red or phenolphthalein indicator. Thirdly, we have to titrate the aspirin solution in the 250 ml conical flask with the diluted 0.1 molar HCl solution from the burette slowly while shaking the flask until the indicator changes color. For phenol red, the color will change from light red to light yellow, and for phenolphthalein indicator, the color will change from pink to colorless. And we have to record our reading at the end point of the titration. And the last step is we have to repeat 2 to 3 times and record all the readings in a table. So this is the problem statements for calculation. 1.125 gram aspirin tablets ASA sample was dissolved in 100 ml 0.25 molar HCl. The excess acid is back titrated with 0.05 molar Na2CO3 standard solution and it required 20.25 ml to reach the endpoint. Calculate the percent weight per weight purity of CaOH2. So we need two equations from the problem statement, and this is the balanced equation that we got from the problem statement. For the calculation, it started by finding initial mole of HCl by using the formula number of mole equal to molarity multiplied with the volume of HCl that we use. So 0.25 molar we multiply with 0.1 liter of HCl solution that we use, and we got 0.025 mole. Next, we have to find mole HCl excess react with Na2CO3 by using the same formula like above. So 0.05 molar multiplied with 0.02025 liter, and we got 0.001025 mole. From the number of mole of Na2CO3 that we got, we can compare the stoichiometric number from the second equation, which is 2 mole of HCl equal to 1 mole Na2CO3. So 0.001025 mole Na2CO3, we need 0.002025 mole HCl by using the formula that is stated here. Next, we have to find the mole HCl reacted. Initial HCl minus with excess HCl, which is 0.025 minus 0.002025 mole, and we got 0.02298 mole HCl reacted. Next, we have to find mole of CaOH2 reacted with HCl. By using the same formula like the third steps, we can find mole CaOH2 reacted, but we have to use the first equation, which is 1 mole CaOH2 equal to 2 mole HCl. So 0.02298 mole HCl, we need 0.01149 mole CaOH2 reacted. By the number of mole CaOH2 reacted that we got, we can calculate the mass of CaOH2 reacted by using the formula number of mole CaOH2 reacted multiplied with molar mass of CaOH2, which is 0.01149 mole multiplied with 74 gram per mole, and we got 0.85 gram. The last step is we can calculate the percent weight per weight purity of CaOH2 by using the formula mass of reacted CaOH2 divide with mass of total CaOH2 like in the problem statement, and we multiply with 100%, and we got 75.56%.
Hi, I am Shahir. I will explain the benefits and challenges of back titration in industry. We found that there are several benefits, namely improved accuracy, enhanced result, which is back titration can provide more precise result for substances that are difficult to titrate directly, such as weak acid and bases of those with slow batch rates. For example, determining the purity of pharmaceutical, where the back titration might not fully react. Second, suitable for insoluble substances. Versatility, effective for substances that are not readily soluble in water, allowing for accurate analysis. Example, analyzing calcium carbonate in cement which does not dissolve easily in water. Other than that, versatility, wide application which across various industries such as pharmaceutical, food, environmental, testing, and metrology. For example, determining the acidity in food product where multiple components might interfere in indirect titration. Last but not least, cost-effective, exam saving, reduce the quantity of reagent required, especially when the primary titrate is expensive. Example, large-scale industrial processes where cost saving on chemical acidification. Furthermore, we also found that the challenges are complexity of procedure, increased difficulty, requires careful planning and multiple steps, which can introduce whenever it's not executed precisely. For example, training lab technician to perform back titration accurately. Second, reaction completeness, accuracy issues, ensuring the initial reaction goes to completion can be challenges, affecting the final results. Example, incomplete reaction of analyzed in environmental water testing. Besides that, time-consuming efficiency concerns generally take longer than direct titration, requiring more time and resources. Example, extended testing times in quality control lab for industrial product. Next, equipment and training results. Extensive, require specialized equipment and well-trained personnel to ensure accuracy. Example, investment in training for lab staff in pharmaceutical manufacturing.
As we discussed earlier, back titration is purposely used to know a concentration of an analyte by reacting it with a known excess of a standard reagent. We take aspirin as the easiest example. Aspirin is also known as acetylsalicylic acid, is used in back titration to assess its purity. From this, we can determine if there is any contamination and also determine the amount of acetylsalicylic acid in the aspirin. Different types of aspirin have different strengths based on the amount of acetylsalicylic acid present in it. Back titration is applied mainly in pharmaceutical, food industry, and in chemical manufacturing. For pharmaceutical and chemical manufacturing, the process is mainly used to determine the number of active ingredients, detect the impurities or contaminants in a sample, and at the same time, maintaining the qualities of the substance. In the food industry, they use back titration technique to determine the amount of salt and sugar in the food sample so that the consumer will aware of the sugar and salt intake in the food. Now that we have come to the end of this video, we all get the new knowledge that back titration is different than than the direct titration technique. It is more accurate in determining the concentration of an analyte using an excess reagent. The reaction of an analyte and excess reagent is still going on until it is complete, in which it has reached the endpoint of the titration. To determine the concentration and its percentage of purity, a calculation is done by the end of the process, as my friends explained earlier. The same goes with direct titration. Back titration also plays a big role in manufacturing industries. From this process, chemicals are produced and tested for a certain level of requirement and end up to the consumers to use it well. Thank you for your time to watch our video. Hope you guys can gain some new ideas and brilliant thoughts after watching our videos. Bye and see you in next semester.